Hey everyone! In this video, I will be explaining the basic concept of analog and digital modulation techniques. This presentation will compare different modulation methods, explain how their modulator and demodulator circuits work, and highlight the key differences between analog and digital modulation. First of all, let us understand what a modulation is. Modulation is the process of changing a carrier signal based on an information signal, such as voice or data, so that it can be transmitted efficiently over long distances. Modulation is important because it helps reduce noise, allow efficient use of bandwidth, and enables multiple signals to be transmitted over the same communication channel. There are two types of modulation. First is the analog modulation. Second is a digital modulation. In analog modulation, there are two. First is amplitude modulation, or also known as AM. Second is frequency modulation, also known as FM. In digital modulation, there are three techniques, includes ASK, FSK, and also PSK. In a communication system, the message signal is passed through a modulator, transmit to a channel, and recovered using a demodulator at a receiver. In this slide, I will be explaining about amplitude modulation, or also known as AM. This is a technique where the amplitude of the carrier signal changes according to the message signal, while the frequency remains constant. In the AM modulator circuit, the message signal is multiplied with a high frequency carrier generated by an oscillator. At the receiver side, an envelope detector is used as a demodulator to extract the original message signal. Although AM is simple to implement, it is highly sensitive to noise. In this slide, this is frequency modulation, or FM. The frequency of a carrier signal varies according to the message signal, while the amplitude remains constant. FM modulators commonly use voltage controlled oscillator, or also known as VCO. At the receiver, a frequency discriminator or phase lock loop is used for demodulation. Compared to AM, FM has much better noise immunity but requires wider bandwidth. This is amplitude shift keying, or ASK. This is a digital modulation technique where the amplitude of the carrier signal changes based on digital data. Typically, a higher amplitude represents binary 1, while zero amplitudes represents binary 0. The ASK modulator multiplies the digital data with the carrier signal. At the receiver, an envelope detector and comparator are used to recover the digital data. ASK is simple but sensitive to noise. This is frequency shift keying, or FSK. This uses different carrier frequencies to represent binary data. One frequency represents binary 1, and one frequency represents binary 0. The FSK modulator uses either multiple oscillators or voltage control oscillator VCO. At the receiver, bandpass filters and envelope detectors are used to identify the transmitted frequency. FSK is more reliable in ASK in terms of noisy environments. This slide shows phase shift keying, or PSK. This is a digital modulation technique where the phase of the carrier signal changes according to the digital data. In terms of PSK modulation, the amplitude and frequency remains constant. The modulator uses phase shifter and balance modulator. At the receiver, a coherent detector and phase comparator are used. PSK provides high noise immunity and efficient bandwidth usage. In this slide, this is a comparison of analog and digital modulation. In comparison, the analog modulation techniques such as AM and FM are simpler but more affected by noise. Digital modulation techniques like ASK, FSK, and PSK provide better noise resistance and signal quality. However, digital systems are generally more complex. Modern communication system mainly uses digital modulation due to its reliability and efficiency. In conclusion, modulation plays a vital role in communication system. The analog modulation is easy to implement but sensitive to noises, while digital modulation offers a better performance and reliability. The choice of modulation technique depends on the application and system requirements. Thank you for watching.
How will we increase the frequency of the message signal? Actually, we will not increase the frequency of the message signal, but we will superimpose the low frequency message signal with the high frequency carrier signal. Hence, the characteristics, that is, amplitude, frequency and phase of the carrier signal will be changed in accordance with the message signal. This process is called as modulation. Let us see how the problems in the transmission of the low frequency signals are overcome by modulation. To overcome the problem of antenna height, if a high frequency signal of 1 MHz is used, the height of the antenna will be around 75 meters, which can be achieved practically. To overcome interference, if the stations transmit high frequency signals like 2 MHz and 6 MHz, then their difference will be high, that is 4 MHz, and thus the waves will not mix with each other. To overcome the problem of poor reception, if the frequency of the signal is high, automatically the energy of the signal will also be high, and hence we can obtain a good quality signal at the receiving end. By using high frequency transmission, we can achieve high power radiation without changing the antenna height. Modulation helps us to replace the wired medium with wireless medium communication. Also, we can achieve a high range of communication by using far. We have studied about modulation and the need for modulation. When the modulated signal reaches the receiver, it is necessary to separate the message signal from the carrier signal. This process of recovering the low frequency message signal from the modulated signal is called as demodulation. Now, let us solve a problem based on height of the antenna. Find out the height of the antenna required to transmit a voice signal of frequency 3 kHz. We know that for efficient transmission, the height of the antenna should be equal to lambda divided by 4. We can obtain the wavelength from the equation shown here. Thus, the wavelength is 100 kilometers. 1/4 of it is 25 kilometers. From this lesson, you have learnt about modulation, problems in direct transmission,